Looks like it works. Okay. So, quick introduction about myself. I think if you can bring my slides up. I work as a principal data scientist with Honeywell, and I have around 13 plus years of experience now. Currently, my work has been related to AI, agentic AI, LLMs. We started back in 2022 when we started with a very, very basic application using LLM, and then is how my journey evolved more into understanding how to manage different components, and that is when I actually realized that there are different components. It's not just calling an API and getting an answer. So today's talk is basically about memory management for AI agents, and I'll briefly talk about multi-agents, but I'll try to keep it to single agents to keep it simple. On the right side of the screen, you do see the brain structure of a human. Any guesses what could be the size of data-wise, as in how many petabytes or how many GBs can a human brain hold? Any wild guesses?
Exabytes.
Okay.
56 exabytes.
Good one, good one. Anything else? Any wild guesses?
Infinite. Because
Infinite.
it will address the new data concept.
Okay, okay. So I was curious about it and I asked ChatGPT like a normal person, and it did a very precise calculation. How many neurons are there, how many connections are there, and it gave me an answer. It was 2.5 petabytes, which is equivalent to watching 300 million hours of YouTube continuously without repeating any shows. So it is actually a very, very, potent structure that we have inside us, and probably we'll never be able to replicate anything like that in the agents. And there are many, many different sections of the brain in the human mind. I'm also interested in neuroscience, so it's very fascinating to me. So today, in the next 10-15 minutes, I'm going to overload you with a lot of information, ideally which will get into your short-term memory. Where I would want to get those into later is in the long-term memory, right beside where you put your Wi-Fi's password. But we'll try to make that happen. Let's see. So, what exactly are agents? Agents are entities, right? Let's keep it simple. So, what we are trying to do is we are trying to build an awareness which is very, very similar to what humans have, right? What we have. So we are trying to have assistants who are intelligent like people, so that people's work get automated in very, very layman's terms. So what do people have that the machine need to have? The first thing is perception. So we perceive things with our senses. Action, we have all these like hands and legs and whatnot for the actions. Perceptions of the agent would basically be through the input, the voice and the text and whatnot. Actions through the tools. We'll talk more about the tools. Besides that, we have the most important thing, which are cognitive abilities. Cognitive abilities are what the big large language models do for the models, right? So, okay. Now, today I will not talk about the cognitive abilities, although there is a lot to talk about it, but today's topic is about particularly memories, right? So, memory, if I classify it at a very, very high level, it will be short-term and long-term memory, right? And I'll be drawing some parallels with the human way of thinking so that it becomes more relatable. So let's say when someone talks to us, right, we actually have two of these, right? We have the short-term and we have the long-term memory. The short-term memory again has the cache memory and the working memory, right? So now that I'm talking to you, everything is getting into your working memory, and some of it in the cache memory. My sentence which I just spoke before this is actually in your cache memory, and the session that is going on, it is a little bit longer term, and that is getting into your working memory. So besides the short memory, we also have the long term memory, right? So long term memory, this is kind of very related. When we have conversations with people, right? Being Indians, when we talk to our families or when we talk to anybody, our friends and anything, there are actually two components to any conversation, right? There is an entity and then there is a data, right? So when my parents compare me to Sharma ji ka beta saying that he earns more than you, the Sharma ji ka beta is the entity and the fact that he is earning more than me is actually the data. So the data can change but the entity is not going to change, right? Episodic memory is actually the knowledge. So when I was 7 years old, I got to know what is the capital of France, and that I remember till today. So that is actually your episodic memory, the knowledge of it, right? Also another thing in the episodic memory which gets in is basically if I talk about you now and 10 minutes later if I meet you somewhere in the lobby and you could refer to something that I talked about, something, the knowledge that you will be like bringing up, right? What did we talk about before this? So that train of thought would also be in the episodic memory. So people who have used ChatGPT, I think everybody has used. When we ask ChatGPT about something, and let's say last week we asked about something and then today I come back and we continue the conversation, it picks up from where we left, right? So that is the episodic memory of the GPT, right? So these are on high level the things. Why does memory matters in the agentic systems? Let's move out the agentic systems for the time being. Any LLM, any kind of LLM solutions, right? Why does it even matter? So, like I was saying, any kind of large language model, most people have till now worked with chatbots, right? We build chatbots on large language models. Now, imagine a situation where you ask what is the capital of France. It has said Paris, and then you asked a follow-up question. What is the best food to have there? You're not saying where, right? So it has to remember what was the last question, what is the context of the conversation. So if it doesn't remember that, then there is no point. Most of the LLM models are actually stateless. It is not supposed to remember things. So any kind of application that is built, ChatGPT is actually an application that is built on OpenAI, right? So any kind of application that we build, we have to articulate it in a way that it becomes stateful and it remembers what we are talking about, right? Prompts and actions, all the prompts, again, whatever prompts we are writing, the system prompt, the question, whatever we are writing, those are stateless. So it is not supposed to remember anything. We have to articulate our application in a way that it remembers the prompt actions plus the responses, and memory is the only backbone of that application that makes it stateful, contextual, and when you see playbooks there, playbooks is another important thing. Once I learn how to drive a car, I should remember it. It's not like I learn it today, tomorrow I forgot. So similarly, any application that we build on LLM, it should be, once it does something, it should be able to remember. Below that, the types of memories, I briefly spoke about it. Working memory, what are we doing right now? Cache memory remembers the last sentence, for example. Session memory, dialogue about a certain topic. Last week we spoke about something. Procedural memory is remembering how to do things, how to drive a car. Episodic memories are long experiences, right? So over a period of time, let's say analytics data. You have analytics data for your company, you have run market research. You want those to be integrated into your application. That is what it means. Semantic memory, right? You have to make sense out of documents. There could be text document, there could be Excel sheets and whatnot. You have to make sense of it. Okay. And then finally, business rules are there, which are static. It is not really very long term, sometimes medium to long term. Business rules are there, they can change. So these are roughly different types of memories that we can utilize. It is not written anywhere in stone that you have to utilize all of this in your solution. The application, when we are building the application, it depends on us what exactly we are trying to build, how much memory, what out of these components we are going to pick up. Right? Yeah, sure.
So, who is responsible to define all this memory? Is it the system, the LLM, or it's the application?
It's the architect.
Architect.
Yes.
Application.
Yes. Application architect. So
memory, right?
yeah, the solution architect.
So it's like short-term memory.
Can you
when you are saying short-term memory, what it signifies? Is it a RAM, it's a cache, or some kind of...
I'll get into the details of it in the upcoming slides. Right. So, agents have patterns. I think anybody who has explored agents here would know this. I'll not spend too much time on this. I'll just talk about roughly what the patterns are. When the first one is basically you're asking a question, it is giving an answer. Let's say you ask capital of France, it said New Delhi. It's not the correct answer, right? So it's going to go into a loop. Tool usage pattern is basically tool is a module of the work, right? It's not calling an API, it's not calling a function. Anything that can be separated from a workflow as a single module of work can be a database call to find something. So that module, one single module of work is basically defined as a tool. So tool usage pattern is a sequence of different tools are there, and then those are utilized to solve your problem. Planning pattern, there is a planner orchestrator kind of logic at the first. It decides what is the task, what has to be done. It is often coupled with the tool usage pattern. We'll see that in the next slide. Multi-agent pattern, it is more complex. It is a combination of different agents that you're seeing in the first three. Okay. Patterns for today, we will be talking on the planning pattern and the tool usage pattern. I'll take you through a use case and I'll briefly tell you how a solution architect decides basically what memory patterns to use, or what, like the bare minimum that you need to build a solution, right? So planning pattern and tool usage pattern is what we are going to use. The definitions are right there. I'm not going to read it out, right? Okay, so let's take an use case. So anybody who has worked in marketing, right? For me, I've personally worked with media companies, and marketing has been one of the business stakeholders that I've worked with. So let's say the marketing team runs multiple paid campaigns across different channels. It could be on social media channels like Instagram, YouTube. It can be offline as well. There could be like hoardings and things like that. But these days it's mostly digital. So this is the use case. Let's say you're running multiple paid campaigns. There is a system that you're monitoring. You're looking at the performance matrix, and then it should advise you, right, based on the results of your last campaigns, based on the market research papers, based on the outcomes, the knowledge, the inherent knowledge. So let's say the user has a chatbot, and the user is asking a question that our CPC is basically your total ad spend by total number of clicks. Basically, you spend some money on the ads, and you have gotten the number of clicks. You are trying to see how much money you are getting out of it, right? So our CPC is increasing on Instagram this week. Should we shift some budget to YouTube? So if the CPC is increasing, it's not really a good thing, right? Because your total ad spend by total number of clicks, you're not really getting those many number of clicks. The denominator is lesser. So it's a higher number. You want to reduce it. So you're spending more money, you're not getting to clicks. So basically, what you're asking is that it is increasing on Instagram. So should we shift some budget to another channel? It can be anything. It can be YouTube or whatever. So if someone asks a market research agent on this, not a LLM kind of agent, a human agent, right? If I am the human agent, if I am asked this question, how do we generally solve these kind of questions? So first thing we think about is there a pattern to the question? Have I heard about this before anywhere? Have anyone asked these kind of things to me before? So that is something. Other thing is, are we picking up from some other conversation? Maybe that person has spoken to me before about it. I have given some answers. That can be a context, right? Besides that, we definitely need to look at the performance analytics. Over the period of time, there would be some analytics data in my database. I have to look into that. Then I have to look to the business rules as well, right? Is it even approved by the business to move it to YouTube if Instagram is not working, right? So these kind of things. And then recent transactional data, I mean, have I signed a contract recently? Let's say last week I have signed a contract with the Instagram influencer, for example, right? Now I can't move. So using all these different factual data and different kinds of data, what I do is I synthesize everything and I come up with an answer. So the answer could be something like this: suggest shifting 10% of the budget from this to that. Right? This is a sample. So let's say what data we have access to. We have access to the chat history so that we know that we are picking up from somewhere or not. We have market research documents and we also have insights. So what are difference between insights, market research documents and insights? Let's say Gartner has done some research on my product, right, on my segment of product. Let's say I sell toothpaste and Gartner has done some research on it. There are papers. Those are market research documents. And then there are insights. Insights are the campaigns that my company has run over the period of time. I have, let's say, run a campaign of buy one get one free. So what has been the effect of that? Or for Instagram, let's say I have run a campaign on Instagram. What has been the so besides that, business rules and facts are also accessible, right? So what do I do with all this? Now coming back to your question that what kind of memory to use. So the things that we should keep in mind when we are designing as an architect is basically there can be a few things. The first thing is the L of the low is wiped out, but it is the speed. So this is the the line between there is the speed and the long-term persistence, and there that side, as you go that side, it is low latency, and as you go this side, it is low cost, right? This long-term persistent will cost you less. So you have to decide, and my tech stack is Google, so mostly all the services that you see here will be GCP tech stack, but you can very well translate it to Azure or AWS. You have like parallels. So here, the lowest cost and lowest persistence is your BigQuery. BigQuery is an analytical warehouse, right? So all the campaigns that my company or I have run before, the results of those are stored in structural database table, which are write optimized, they are not read optimized. So what will happen is if you plug that in directly, it will increase latency of your application. A chatbot behind which the BigQuery is running, it will increase your latency compared to a chatbot behind which, let's say, PostgreSQL is running, because it is read optimized, right? So you have BigQuery option, you have SQL option, you have no SQL option, which is Firestore, and then you have Redis, which is your cache memory, right? So what do we store where? That is a decision that the architect have to take, right? So session or memory, right? Session or episodic memory is basically the chat history. You have to remember the context. That can be stored in the Firestore, right? Firestore, why I am saying? Because it is a non-SQL database and it can be a key value pair of the chat history, basically the session ID, it could be of the user ID, session ID, combination kind of thing, along with the chat history, right? Besides that, because it is low latency as well, flexible schema, cost effective, so these things you have to always keep in mind. I think everybody here, there are very, very experienced people in the architects in the crowd, so you'll relate to this. So Scratch module, the working memory, I mean what exactly are we talking about right now? That has to be stored in the Redis, right? So that the last sentence of the chat, you don't have to get it from somewhere very slowly. Log module, analytics, BigQuery, here it can be used, but it is not suggested to directly plug it into your application. It is probably better to get it into a SQL and then, get it to the front end. Semantic module, in GCP we have vector databases. So PG vector is the preferred vector database. There are ChromaDB, Pinecone, these kind of vector databases as well. Discovery Engine is one of the services that GCP provides. Similar services are there in Azure and AWS, you can think of. This is basically reading and understanding documents, market research PDFs, 100 PDFs. We're trying to get the crux of it. So coordinator module, right? This is something very important, and we'll see in the next slide why. Let me quickly go here, right? So this is a proposed architecture. It's not set in stone, right? So what really happens, I told this is a combination of the planner module and your two slides back, right? Here, planning pattern and tool usage pattern. So here, what we are doing is we are using the planning pattern here, which has procedural memory, right? The planning pattern, what it does, it will take up the question, it will try to make sense out of it, it will try to orchestrate what is needed out of it, and in what order is it needed. It will create a plan. Generally, if I talk in the terms of coding, what we do is we give it a prompt and then we give it an example in what format we need the plan. the plan format is mostly in JSON. It could also be a XML schema that you get. So it will give you a plan that, okay, step 1, call this, step 2, call this, like that. So what it does is it orchestrates the module in what order it will do, and it also tells you what format the output should be. So output sometimes the LLM will start telling you stories, right? A very, very long story. It should not be, it's not expected. So what we do is we always bind it into the output format. The output format of it is most often in JSON format. Okay, right? So here for this use case, right? The example of this is the planner module. The first thing, as I said, what we do is, are we picking up from an older conversation that is going to come from your session memory. And if you see here, there is a scratch module. This thing is like a whiteboard. So whatever the session module understands, yes, we are picking up from an older conversation, and it has the relevant chat history. It has given it to this. This is the whiteboard. It has written it here. This communicates with the long-term memory, which is a log memory. How has the campaigns in the conversations performed in the past, right? How have the Instagram campaigns performed in the past? These are my analytics reports in cells. Comes back to here, writes it here. Semantic memory, are there any relevant information in reports and documents? Gartner, Deloitte documents, 100-page PDFs, is it there? Comes back. Writes here, long-term memory log module, which campaigns in the recent campaigns and how they are currently performing, right? It's a very, like, very recently what has happened. That is also needed, along with the long-term what has happened. So everything is there here. It's in your scratch module, and finally the scratch module will give it back to the planner module. What the planner module will do is it will synthesize the answer, utilizing everything that it knows till now, and it will create a JSON format of that, right? So this is what it is. I know it's a lot to take, but I'll quickly complete this so that it's on time, and then we'll have some Q&A time.
So
yeah.
So we need to define all these flow.
Yes. So these are essentially your modules. You're writing let's say you're writing a fast API code, right? So what you will do is you will write different services for it, and let's say your chat is an endpoint. Your endpoint chat will basically be your planner module, right? And from there the orchestrator kicks in, and after that it has the sequence of different services that it will call, and then finally it will come back to your chat module's code with the synthesized answer, and that is what goes into your content, right? I'll take more questions, but before that, let's see the overall architecture. So this is very bare minimum, but I know a lot can be done around it, and people who are like more experienced would also add on to this. So let's say the user talks to the front end there. What happens is we always put a proxy there in between the actual cloud run endpoint. Cloud run is where you host your APIs, right? The web framework. Let's say fast API you have written, you host it in Cloud Run. It's a managed service by GC. So authentications are handled by the APG. After that you get into the Cloud Run. Cloud Run has the fast API or class whatever endpoints you have. Like I was saying, the planner modules /chat is the URL, for example. Gets in. Then this is the whole thing that I showed you before. Memory layer is parallel to this. Basically the scratch module and all the other modules have access to this. These are your memory layer. Most often secret manager is used, but sometimes Vault is also used. So after we get everything, it goes back to your Cloud Run. We have the observability layer. There are other services as well which could be used, but these are cloud logging, monitoring, and data reporting. You can also trigger emails if there is something emails or chat things or things like that. Most often than not, we have a looker dashboard there, which basically tries to keep a track of what has been happening, how many times it has failed, how many people have actually interacted with it, those kind of things. So user there have an access to both of this, the front end and the looker dashboard. So yeah, this is the bare minimum of it. I think this is the end of my presentation, and these are my LinkedIn and Medium scanners. Do feel free to follow me for more conversations. Also, I'll take the questions right now. I think we are on time, isn't it? Yeah.
So I have a question here with
Yeah.
respect to the memories. So let's say if, I mean, like you said, right, we should look into the